Hello, knock knock. I'm back with the next session of the chapter Current Electricity, which is the Unit 2 of CBSE Grade 12 syllabus. What we studied last time: electric current, electric drift velocity of electrons, and current, the relation between them. And now, what will we study today? Ohm's law, resistance, factors affecting resistance, and the color code for resistors. Let's first do the recap. Which were the topics that we studied last time? The first one was current carriers, solids, valence electrons, liquids and gases, they have ions. The second topic we studied was drift velocity. It is the average velocity with which the electrons get drifted towards the positive terminal of the battery under the influence of external electric field. The formula was Vd is equals to minus of E tau by m. Then we studied mobility. Formula was mu is equals to Vd upon E or Q tau by m. The unit was meter square per second per volt. Then we studied about the relation between current and drift velocity, which was I is equals to ANEVD. Now, let us start today's topic. Who is this gentleman? Do you know this gentleman? He is George Ohm. Now, who is this George Ohm? He gave the famous Ohm's law, which is under similar physical conditions, the amount of current flowing through a conductor is directly proportional to the potential difference across its ends. Mathematically, V is proportional to I. If I remove the sign of proportionality, I have to put a constant, that is V is equals to IR, where R is the resistance of wire we got from the proportionality constant. Now, as V is directly proportional to I, so the graph between V and I is a straight line, and the slope of this graph will give me the resistance. So if I can find out the slope, I will get the resistance. Let us deduce Ohm's law using the things that we know already. You remember I is equals to ANEVD. Let's put the value of Vd, which was E tau by m. Negative sign is not taken because we already know electron is negative, so we are not taking. Do you remember the formula for E? It was V by L. So let's substitute that also. So what are we getting? ANE square V tau by ml. Now just rearrange the things like this, that is V by I is equals to ml over ANE square tau. Now here m is a constant, L is a constant, A is a constant, N is a constant, E is a constant, and tau is also constant if you are not changing anything. So can I write V by I is equals to R, that is the constant, and eureka, we got V equal to IR, where the formula for R we found out is ml over ANE square tau. Okay. Now let us find out the limitations of Ohm's law. The first limitation is that the relation between V and I is non-linear. That means, as I said, according to Ohm's law, the graph should be a straight line, but here, can you see? It's not straight line, it is curving up. This is because of the heating effect of current. The second is the relation between V and I depends on the sign of V. Can you see here? If V is positive, the graph is separate. If V is negative, the graph is different. By the way, this graph is an example of junction diodes. About this, you will study in the unit semiconductors. Let's find out the third limitation. It is that the relation between V and I is not unique. That is, let's see this graph. Can you see, for two different values of V, I am getting the same current. So it's not unique. It should be unique according to the Ohm's law. Okay, by the way, this is a graph for gallium arsenide, which is an LED. Now, let us understand this thing, electrical resistance. The symbol is this one, which you already know from your grade 10 studies. Okay, now what is resistance? It is the ratio of potential difference across the ends of a conductor to the current flowing through it. So the formula is R is equals to V upon I. Okay, from Ohm's law. Okay, SI unit is ohm. 1 ohm is equals to 1 volt by 1 ampere. The dimensional formula is ml2t minus 3a minus 2. And what is the cause of this resistance? Do you remember the drift velocity thing? In that we said the electrons are moving towards the battery's positive terminal under the influence of electric field. But between two successive collisions, they were moving in a straight line, but then they were colliding. When they were colliding, so what was that? That is the resistance. So it is the opposition offered by ions and atoms in a conductor. What are the factors affecting resistance? So do you remember this formula? R is equals to ml over a n e square tau. Here mass is a constant, E is a constant. Rest all the things are the factors. Let's see the first one. Length of a conductor. Can you see from the formula? It is directly proportional. That means R is directly proportional to L. Okay, that means more is the length, more will be the resistance, and vice versa. So I have taken two cylinders of different length. So which one is having the more length? The second one. So it will have the more resistance also. Second factor, area of cross section. Can you see? Resistance is inversely proportional to the area of cross section. That means more is the area, lesser is the resistance, and vice versa. Here I have taken a thicker and a thin resistance wire. Okay, now the thicker one is having more area, so less resistance as compared to the other one. Let's continue to the third factor, which is temperature. But here I don't find temperature, but I see tau, which is the relaxation time. Can you see? R is inversely proportional to tau. Now let us recap. What was relaxation time? The time interval between two successive collisions is called as relaxation time. Okay, now if I increase the temperature, what will happen? They will collide more frequently, that is tau decreases. So can I say that tau is inversely proportional to temperature? Okay, so if I see the two, what can I say? R is directly proportional to T. Okay, that means more is the temperature, more will be the resistance, and vice versa. The last factor N, that is nature of material. Okay, here R is also inversely proportional to N. Okay, so that means more is the number density, lesser is the resistance. Eureka! Number density N is more for conductors because conductor have more number of free electrons per unit volume. So number density is more. That means what will happen? They will have less resistance. That is the case. That's why they are conductors. In case of insulators, N is very small, so resistance is very high. Okay. Now, what is this thing? This is a resistor, and what we will study, the color coding of resistors. Commercially, there are two types of resistors: wire wound or wire bound resistors and carbon resistors. So the wire wound resistors, so you can see from the figure that they are winding wires of an alloy, or they are made by winding the wires of an alloy, and the resistance is small. What was the second one? Carbon resistors. So these one, they are made from carbon, so they are compact and inexpensive, and the resistance is very high. And the carbon resistors, they are small in size, so their values are given by using the color codes. So let us try to understand the color coding of resistors. So the first strip represents the first significant number. The second strip B represents the second significant number. The third strip C represents the multiplier, and the fourth strip D represents the tolerance. In the next slide, I will explain how these things. So, this is the color coding table. So we have black, brown, red, orange, yellow, green, blue, violet, grey, white, gold, silver, no color. You start with the number 0 from black and then you continue till white, that is 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In multiplier you again start with 10 to the power of 0 to 10 to the power of 9. For gold you go to 10 to the power of minus 1 and silver 10 to the power of minus 2. Tolerance is only for gold, which is 5%, silver which is 10%, and no color, that is 20%. Now you must be wondering how to remember this. So what we are doing, we are taking the first letter to make an acronym. So here it is B, B, R, O, Y, that is ROY. B, B, ROY. Then for green we are great, Britain, very, good, wife, gold, silver. So this is the acronym. Children, the key is the first one is black with number 0. Okay, the second one is brown with number 1 and the third be blue with number 6. Now, let's see a few examples. So these are the two. Let's solve the first one. Okay, in the first one, can you see the first strip is red? So red means 2. Okay, second is also red. So again 2, that is 22. It's not 2 plus 2. It's the numbers that you are just putting it. So first one is red, that's why 2. The second one is red, again 2, that's 22. The third one is again red. So what we are getting? Multiplier. So 22 into 10 to the power of 2 ohm, and then it is silver. So plus minus of 10%. Let's see what is the answer. Ah, that's correct. Now, can you find the next one? In the next one, the first one is yellow. Yellow is 4. The second one is violet, 7. That is 47. The third one is brown into 10. That is 470 ohm. And then gold, that is plus minus 5%. Wow. Again, it's correct. Okay. Now, let us recap what we have studied. Topics that we studied. The first one was Ohm's law, that under similar physical conditions the current is directly proportional to voltage, V is equals to IR. Next we studied were limitations of Ohm's law, non-linear, okay, it depends on the sign of V and it is not unique. Then after this we studied resistance, which is the ratio of V and I. So R is equals to V by I, the unit was ohm. Okay. Then we studied about the factors affecting resistance, which was length, area, temperature, nature of material. And the last thing was, for example, we studied about color coding of resistors. Okay. So let's do a few questions in the assignment. So the first one is, there is a graph. In this graph, what you need to find out the negative resistance and the place where the Ohm's law is obeyed. The second question is again a graph question. It's a VI graph. From this you have to find out which of the temperature is higher and why. The third one is the two wires are given. One is a copper, another one is a magnetic wire. They have the same resistance and equal thickness. You have to tell which is a longer one and you need to justify. So this was the one, children. I hope you have understood. Do come for the next one.